words don't come. I was working on something and they pulled me in here to introduce our next speaker. So my brain is a little bit in a different context. We have met several times before, and it was actually you were doing very different things, and it's quite fun to see how you moved into a world where we thought, low-code platforms, there's no Axon to find in those. And then you came to us, we need to talk about something. There's, what, really? How? So I'm really excited about this journey that you're going on. So please, everyone, welcome Jakob Hützel.
Hello, thanks for the warm welcome. I need to admit I'm pretty nervous because having a presentation slot after Martin's great live coding and before lunch means I'm now between you and lunch. So I need to be at least entertaining and do something that hasn't been done before. I considered before juggling or standing on one leg and whistling the anthem of the Netherlands, but because I'm sure that hasn't been done before on Axoniq stage before, but I'm not that good at juggling. I don't know the national anthem of the Netherlands, so that would not be an option. I hope you are not desperate, but I can provide something that hasn't been done before because, at least to my knowledge, no one has attempted before to do event sourcing with a low-code platform or with Mendix, with Axon Framework, and that's exactly what I will be talking about in my talk now. My name is Jakob Hützel. I'm a software developer at Asasis. Asasis is a Swiss-based provider for product lifecycle management solutions. We are specializing in the regulated industries like the medtech industry, or we have a special focus on the medtech industry. I joined, or to put it simple, what we are doing is we are helping your average medical hammer incorporated to develop, build and sell their medical hammers in a lot of different countries according to all laws and regulations in those countries. And that's getting a lot of laws and regulation which require a lot of documentation, a lot of audit and a lot of QA throughout the whole process, and we are helping our clients with software to manage these processes. I joined the team in June last year during a internal restructuring where they tried or attempted to internalize their product development, and our first task was to start a new product development or to start off a new product development. And as you know from any real life project, from your own experience probably, we were able to start off with a clear set of requirements. We were able to just sit down, think about a tech stack, and then just get going and implement the first features. But yeah, that's not what real life is. I think you know that. Of course, real life is different. And what we started out with instead was a set of rather vague requirements to build a regulatory information system. And the other thing was we started out with a stack, with a tech stack that we didn't know really or we weren't familiar with, and it promised to allow rapid application development, but neither me nor anyone in my team had a ton of experience building applications with Mendix in that case. So the developer in me became rather impatient, or I jumped to the technology first because that's what interests every developer, and I started learning Mendix. That's why I can now present the Mendix Rapid Developer Badge on my LinkedIn page and call myself a real Mendix developer. And I'm now also part of the more than 300,000 developers or Mendix developers worldwide. It's a growing community. I would be curious, is there any fellow Mendix developers in the audience? Who of you has heard of Mendix before this talk? That's great. I didn't expect that much. Who of you has hands-on experience, used Studio Pro, and coded actually with Mendix. So I'm the only person in the room, and I don't need to ask if any one of you has developed a production application that really hit real users, and I did not, because we are still waiting for our first release. So there's no one in the room that has actually deployed a production application with Mendix, but I want to give you some brief context about what Mendix is. Mendix is a low-code platform which is focused on building CRUD-style applications, and as I said before, it promises to allow rapid application development by abstraction. It provides full stack, so you can develop front-end and back-end in one dedicated IDE. The development environment is called Studio Pro. You will see that later. Mendix applications are by default 12-factor ready, and by that definition, cloud native and containerized, so they are very portable. And due to that, Mendix applications also allow a variety of different deployment options, including public, private, hybrid cloud, or also on-premise development, on-premise deployment, of course. And most importantly, for any serious software developer, the IDE also provides a dark mode. There are only a few concepts you need to understand to develop Mendix applications. First of all, you could give your application structure by creating modules and folders. So you can create modules that contain their own little domain model. And one important thing about these modules is that you can also export them and share them with different applications. So you can also create reusable modules that can be used in other applications. There's even a marketplace where you can share modules and give them to other developers. The next thing is to exchange information in your application or with other systems. You build domain models in your modules. Domain models consist of domain entities. There are 3 different types of these entities, which we will see later. There is persistent, non-persistent, or view entities. Persistent entities are obviously entities that are stored in the database engine that is configured for your Mendix application. A non-persistent entity is something that lives only in memory and is used to exchange information at runtime. And a view entity is pretty much what an SQL view would be. So you define a query that queries information from other persistent entities. To model behavior, you can create microflows. They call it at Mendix. It's a flowchart-like structure where you can express your application logic with predefined actions and also control structures like decisions or loops. And you can even create custom actions that can be built with custom Java code. So you can extend your the Mendix standard capabilities with your own Java code, but you should use sparingly because it would make using a low-code platform obsolete if you code everything with high code. And last but not least, to get full stack, you need some presentation layer. Mendix provides that with pages, snippets, and nanoflows. Pages are also obviously web pages that can be created using pre-existing widgets. So you can pull in widgets in a what you see is what you get style editor. And there's a lot of widgets also already included. There's even more widgets available on the marketplace. And the nice thing about those is that the data binding to the persistent entities or to the entities I explained before is automatically created, so you don't need to care about getting data into those widgets. That's the beauty of low code in that case. That's, I think, enough context for following the rest of the talk about Mendix. So let's get back to our little story. As soon as I had satisfied my curiosity about Mendix, I realized we still have another challenge to manage. We still didn't know what we should build. And we knew that the task was to build a regulatory information system. I explained before that there's a system that should help regulatory affairs teams in the medtech industry to manage their market authorization projects, and also to manage the market authorization status of their whole product portfolio. And that can grow big if you think of thousands of medical devices that are produced by a medical device manufacturer. And yeah, we had access to medical affairs professionals, but we hadn't decided yet on how we would get requirements from them. And while I was researching Mendix, I remembered that I have read the main claim or the initial claim of the two founders, which are Dutch guys, by the way. So Mendix is a Dutch-based company. The main claim they said that should be solved with their platform with Mendix is that they close the gap between business and development. And that rang a bell because event modeling claims to do the same thing, but in terms of requirements. And the nice thing, if you join a new company or a new department in a company that is newly formed, is that you can participate in shaping the tools and processes to be used. And so we decided to use event modeling to structure and document the flows for our regulatory information system. That went pretty well and helped us to structure the scope of our application. What you see on the screen is actually a part of the event model we sketched out with Martin's event modeling tooling. And as soon as we had sketched out these flows to know what to build, the developer in me again became very impatient, and I wanted to know how should we then actually implement it with Mendix? How would that look like? And my question soon was, how could we build that so that it would also scale and allow us to build a complex application? The structure of Mendix applications implies a lot of this CRUD style, and that also comes with the limitations that are known, which is first of all, this one-fits-all domain model and this high coupling between the components. And that problem even becomes bigger as the application complexity grows or as the team size grows. And having had experience with Axon Framework earlier, and I have built event-sourced applications earlier, I pretty soon asked myself if it would be possible to build an event-sourced application using Mendix. And I started doing a bit of research and found a Mendix module on the marketplace, which is called Mendix Business Events. But it wasn't really about event sourcing. It was more event streaming with Kafka, and it was not focused so much on the infrastructure you need for an event-sourced application, like a proper event store and the whole infrastructure you need. So the question was, could we maybe integrate the Axon Framework with Mendix? And with my previous experience with Axon Framework and the knowledge of the Java capabilities of Mendix, I pretty soon started a pet project and tried out how far we should or must bend Mendix to make it fit. And the question I asked myself was, will it blend? And I guess it did not so bad. Otherwise I wouldn't be standing here. And this was really the fun part of this whole journey. I think the core of the integration took maybe 2 or 3 working days to come up with a proof of concept so that we saw it could work. I guess most of you are at least familiar with Axon Framework. So the main concepts, or the 2 main concepts you have in an Axon Framework application, are the message payloads and the message handlers. So the message payloads, the events, commands, and queries that you use to exchange information, and the message handlers, which is the business logic to actually handle those payloads. And we needed to map that to Mendix concepts. And the first thing we did, and it was pretty straightforward, was mapping those two concepts, message payloads, it was pretty clear to be express them as non-persistent entities because we didn't need persistence for commands, events, and queries. The commands and queries don't need persistence at all, and the events get persistent with the event storage engine of Axon Framework anyhow, so we didn't need to take care of that. And for the message handlers, it was also pretty clear to use these microflows, which is the way to express application logic in Mendix. Next thing was a bit trickier. It was hooking up the message handling microflows you express in low code with the Axon Framework configuration. It is not really possible to annotate or add metadata to Mendix microflow. So what we did is we used a capability of Mendix, or a side effect of Mendix, because every microflow you define in the low-code platform also has a representation in Java. So there's a method call you can use to call this microflow actually, and this method call is automatically generated, and you can use it from your custom Java code. And what we did now was that we wrote a little piece of code, a message handling adapter that runs at application startup and dynamically scans for those microflows, for those message handling microflows. We used a naming convention. We just prefixed our message handlers with a certain name to know it's a command handler or an event handler. And then we wrapped that in a dynamic Axon enabled class. So as usual, you would usually create a Mendix aggregate class, for example, with these annotations. We used ByteBuddy to do that, and then we instantiated this Axon class and hooked it into the normal Axon Framework configuration, which was nice because we didn't need to mess around with the Axon Framework too much, and we didn't need to mess around with Mendix too much. It was just this little piece of glue code we needed to implement. The next thing we needed to do was to take care of message serialization. That again was pretty straightforward because Mendix provides a serialization feature out of the box. You can at development time explicitly define JSON or XML or whatever representation for your domain entities, and you define import and export mappings that map the fields of the serialized representation to your entities, and we just had to wrap that in the serializer interface Axon Framework provides anyhow. And yeah, that was it. Again, it was pretty straightforward. And the last thing we needed to do was to allow us to integrate our application logic, so our message handling microflows, with the Axon Framework. For that, we created some custom actions. I said before, you can also write custom Java actions for your microflows. The most important ones being sending a command via the command gateway and applying an event during command handling, which allows us to get the events to the event store. All of that went into a nice little Mendix module. As said before, you can share modules between applications. So all of the Axon Framework integration was nicely integrated in an encapsulated module. And yeah, we were done with our integration. And the next thing I want to do is now with you share the Jabbert time. Do you know what Jabbert time is? I hope you can see one more again, because it's yet another bike rental demo time. I didn't prepare a different one. And fun fact, also Mendix uses for their showcase the bike rental domain. So it seems to be very Dutch. Okay, so I brought the bike rental demo with me, and I've already implemented some slices. So I've started a Postgres database and the Axon server in the background that should run now, and we can quickly access the. So I've also started in Studio Pro the application that runs, and I can now here we go, switch to the application. We have an agent role and we have a renter role. There we go. Sorry, I cannot use my mouse, so I need to use the touchpad. Not used to that. Okay, and then yeah, we can register a new bike. Let's register a city bike in Amsterdam. Let's register city bike in Rotterdam. And another one in mountain bike. Okay, so we have 3 bikes. Then if you request a bike, it will create a payment, which we could confirm automatically. We do it manually, and then you see it in the rented bikes overview. So the application works. You also see the events here appearing in the event store, which have, as I said before, their JSON representation. And what I want to do now is to quickly implement the return bike slice to show you how this integration actually looks like in Mendix Studio Pro. So the first thing we are doing is to create our domain entities, our message payloads. The bike returned event already exists because we are using it in a different read model. So first of all, we create the return bike command, which is a we have a marker entities. So for commands and events, we defined in the Axon Framework module some marker entities, which already contain an identifier that was necessary. And we need the location and the rental reference as the fields. So here we go with the location and the rental reference. It's good. So we have the fields defined. Then Mendix also comes with role-based access control on the entity level. So we need to make sure that our rental agent is able to create the command and interact with it and write all fields of the commands. So we create the access rules. And next of all, we need also to make sure that we create the mappings. So to create the serialized representation, which is a JSON structure for the return back command. We have the that's a bit tedious. You need to do it manually, but I'm looking into ways to make that automatic because doing the mappings is very boring work, but you need to do it. We need the location and we need the rental reference. Okie dokie. So we have our representation, and then we need to explicitly define also the export and import mapping. So we need to tell Mendix how to map actually the return bike command using this structure, return bike command, and we want to map all of the fields in our serialized representation to our return bike command entity. We can map the attributes automatically by name because we named them the same way. And oh fun, we need to also create the corresponding import mapping. Return command. Okay. So again, we use the serialized representation we had, the return back command, and we want to map all fields, and we want to map to our return back command. That should work. Okay, so what we have done now is we have created our message payload, we have mapped our message payload so that it can be serialized and deserialized in the Axon Framework infrastructure. What we need to do next now is to create our command handler. So we want to handle the return back command. We put all of the resources belonging to a certain slice into a separate folder, so we can also structure the code base a bit. And now we follow this this naming convention. We build a command handler that belongs to the bike aggregate. We're still using aggregates, but there's a huge potential to switch to the DCP implementation with the structure we're already using, and we handle the return bike command. Okay, each command handler, as you would also make it in Axon Framework, the command handler has access to the aggregate state. In that case, that's again bike state. That's a non-persistent entity we already created, and that gets hydrated with all the event sourcing handlers. We will implement an event sourcing handler in a minute. And it also takes, of course, the command we want to handle, so the return bike command. Yes, there we go. Okay, and what we want to do now is we need to check if the reservation is confirmed, because we can only return a bike if the reservation is really confirmed. We don't want to return bikes that are not in use at the moment. So we use is in use. We use the bike state and check if the reservation confirmed is true. If that's not the case, we throw a command handling exception. That means bike not in use. And if it's the case, we create a bike returned event with mapping the fields from the command that are relevant. So return bike command, the ID. We use the rental reference, and we use the location, of course. Location. Great. And we need to, of course, apply that. Apply event. Okay, that should be it. As because this is the only event marked with the event marker entity. Mendix already knows that it could use that as the input here. So we are done with our command handler. And the next thing we want to do is to add event sourcing handler. Again, we have the naming convention to identify it. We assign it to the bike aggregate, and we handle the on bike returned. An event sourcing handler also has access to the aggregate state again, so we are using the bike state as an input. So I guess you already guessed, the yellow arrows are parameters, input parameters to macroflow. And the next thing we need is, of course, the bike returned event. Okay. So we have the information ready, and if the bike returned event comes here, we can change our bike state, because we now know the bike is available again. Then we also know it's not reserved by anyone, and we also know that the reservation confirmed is false. So it's resetting the state, and as a convention we also need to return the bike state from our handler, sorry, and also define that as the return type of the message handling microflow. So now we have created the command handler and the event sourcing handler, so the application should be functional, but we don't have a way yet to interact with it, so we need to create a screen as well, or a button to return. That's the thing we will do now. So we have our rented bikes view. That's how a page looks like in Mendix, and here we have the table. We want to add a button to return the bike. For the sake of simplicity, we are returning all bikes to Amsterdam because it's easier. So return to Amsterdam. We want to call nanoflow. A nanoflow is a way to express front-end or presentation logic. So here we go. We create a new nanoflow, which is in the return bike, which is called onClick return bike. It takes our rented bike, so that the entity that is shown in the table as the input, and here we can just create a return bike command, set the ID of the bike, which is the rented bike ID, then the rental reference, and the location. So we have no location available, but we want to hard code it. So I would just add a string here for the location as an input, and can also configure that here. Location. Okay, that's it. And of course we need to send the command. It again chooses the command already as the input because it's the only implementing the command interface. And yeah, here we need to specify the location. We said we return to Amsterdam hard-coded. And what we want to do also is to encapsulate this functionality, because now we have changed the rented bikes page, but it belongs actually to another slice. Yeah. So we extract a snippet for return bike, and we can move that snippet as well here. So everything is nicely encapsulated in this folder. Final thing we need to do is to again allow our rental agent to call this, to access this microflow. And I think we should be good to go. We need a full restart because now the application needs to restart and to pick up those new message handlers. And in a few seconds, the application should start up. And we should be able to return finally our bike to Amsterdam. I hope the demo gods are with us here. What is the time, by the way? Are we? Okay, yeah, that should be fine. Okay, so application is starting up now. The Axon Framework setup configuration is running and is recognizing all of the message handling microflows in that case. And yeah, now the application should be reloaded. We can log in again as the demo agent and the demo renter. Have a look on the available bikes, and as we return our bike to Amsterdam, it should again appear here, and we would also see the corresponding event here. So it's just 11:45. And yeah, it's the bike return to Amsterdam. Okay, that is pretty much what I wanted to show you about the workflow it enables with this integration. What I just recently recognized was how nicely the event model shines through in the low-code representation, and I think that is because the low-code platform also does a kind of an abstraction, pretty similar to how I think Alat put it I think you put it yesterday in your keynote. It's just the right level of abstraction that event modeling puts, and I think on the implementation side, low-code does a similar thing. And as you see, the green boxes, the read models, are usually represented also in the same way, even with the same fields in the domain model you create in Mendix, usually as persistent entities or as view entities. And another thing is what we just did now with this snippet we created. You can also nicely encapsulate your UI functionality. So I could have put the button in this page in the table, but I deliberately extracted it to a snippet, and the snippet exactly takes the rented bike entity, which is the representation of the rented bike read model in the event model. So if there's an arrow from a read model to a screen in the event model, you would have snippet parameter as input for your snippet that represents the screen in your event model, which is also nice. And yeah, all of the code that belongs, or all of the sources that belong to a slice also nicely go into a folder. So when you are touching a slice, you're not touching resources of another slice, which is also a nice effect. And yeah, in general, also this is a nice effect of the event model, or more of the vertically sliced architecture, because it's a huge game changer for developing with Mendix, because if you need to resolve conflicts in Mendix, that is not really funny due to the fact, or due to the nature of Mendix, because it allows version control, it allows Git to be used, but the problem is you're very limited in the tooling, and it's not what you're used to if you're using a diff and a text-based high code thing. So that's really a nice effect. Where are we standing now with our regulatory information system project? We have obviously completed our proof of concept with quite a success, so it works, and we dared to put our development efforts 100% on this approach. So we started to implement it that way, and it was quite successful. We already implemented in the last 120 working days, I think 84 slices, doing other stuff as well, but that accounts to 1.5 days per slice with less than 2 developers. I'm doing a lot of event modeling, and another developer is doing Mendix development. And yeah, that's letting us keep a stable pace even as the application grows. And we expect also that the if we scale the development team, that this would stay stable due to the vertical slicing. I could now go on a lot about saying how nice our integration is, and don't get me wrong, it is, and it was fun to build it. But and it was also due to my opinions about how this all would work out that we decided to do that, and that puts kind of a responsibility on me. But what making me confident in this decision is not that we built our integrations so bulletproof. It's actually a different thing. It's that we have used event modeling to sketch out our requirements in the right way, so to get our requirements right, because I'm pretty confident we could rebuild the whole application in another tech stack without any problem, with considerable but limited effort, because we know what we need to build, and that's the important thing. So this talk is not entirely about low code or not, and low code or Mendix is not better or worse than high code. it was actually just we had the right skills in the team, and we had the right strategic alignment to do it at that point. But you could use any other stack. So if you want to take home something from today, I would say if you get your requirements right or unambiguous using a technique like event modeling, it doesn't really matter which tech stack you choose for the remaining 20% effort of implementation to make you really faster delivering value. Or if you want to put it like Steve Ballmer would say it, requirements, requirements, requirements. That would be what he would say. So I thank you for your attention, and we can have questions at lunch, I think.